So starting with the SAP HANA architecture, when you see the SAP HANA, so in SAP HANA appliance, that is your SAP HANA database. Okay, I think some people have not got the link. Just 1 minute. Hello. So here we have different server. This is a HANA database, and within the SAP HANA database, we'll be having the name server. This is one server, the one service which will be running. And one more server what we have is your index server, statistic server, then we have pre-processing server, then we have access engine. So these are the core services which will be running within the SAP HANA database. So here, when you see in a SAP HANA database, the first thing is your name server, which will maintain the landscape information. Okay, the whole landscape information, like how many nodes you have at, and what is the IP address and where the data is located, right? So all the details about the topology of your system landscape will be stored within your name server. The second server, which we have, is index server. This is a core server which will be used for storing the whole HANA database. So your row table as well as column table will be stored within your index server itself, right? So when you tell that, when you want that SAP HANA database has to store some data, then you have to make sure that your index server is up and running. So if the index server is down, then there will be no use of having your pre-processing server or access engine, so you will not be able to fetch the data out. Right? So index server is a core. Then we'll be having your statistic server. So this will be collecting the performance data about your SAP HANA. Next, we have your pre-processing server. So pre-processing server will store the text analysis, right? The text data will be for text processing. So we'll be using your pre-processing server. Now coming for, as I told that in SAP HANA, we have a default web server. So there is a lightweight web server which will be installed, right, by default. So this is your access engine. So access stands for extended application services, right? X stands for extended application and S stands for your services. Okay, so these are the core servers which will be running within your SAP HANA database. And after that, we have SAP HANA Studio repository. So this is for your HANA Studio, because with the end user we'll be having this HANA Studio repository. And we have SAP Host Agent, which will be used for, which will be able to enable or stop your remote services into the server. And we have software update manager. This is the old one, right? So we have your LCM again, so which will be managing your software updates of SAP HANA. Now you can have a single node server with all these servers which are running up here, or we can have your multi-node server also. Okay, so we can have multi-nodes where within this we can have multiple index servers as well as your pre-processing servers, right? Then after that, access engine will be the single one which will be there. So the main thing is, for the storage of the data, our index server is a core which will be stored in multiple servers, right? So if any node fails, then automatically the standby node will be coming to the picture. So we can have multi-node configuration also, or we can have single node configuration of your SAP HANA. So when you see here, this is a single host configuration. And if you have multi-nodes, we call it as a multi-node configuration. Okay. So I will just go to this. So just to give you a small introduction here. Say for example, index server. This is the main core or the main component of your database, and which will be storing your actual data. As well, we'll be having your engines for processing the data also. And index server will be processing your incoming SQL as well as MDX statements, okay, of your authenticated sessions and transactions. So the meaning of this index server is, like I'll try to explain it. Let me take like this. For example, you have your SAP HANA database, which you have installed it. So within the SAP HANA database, as I told you, there will be different services or servers which will be running. And each particular server has a different purpose. Right? Now say for example, I'll take this as a name server. And I can take this as an index server. I'll take it as pre-processing server. Right? And I can take, for example, access engine. Say, for example, statistics server. Like this, we have different servers. So altogether, one HANA database will have multiple servers which will be there inside the system. Out of these servers, the core server for us is your index server, where your actual database will be stored here. So none of the servers will store the data, only your index server will store the data. And whenever you're trying to use some applications to fetch it from your HANA database, always it will be referred to your index server. Right? Now, for example, I have HANA Studio. I'll call it as HS. And here I try to write some select statement as select star from employee table. And when I execute this, then normally it gets authenticated within the HANA server, right? Then after that, it goes to your database and fetches the data. But it's the same thing if you want to do with an web page. Say, for example, this is my web page, Internet Explorer. And from there also, I'm trying to connect to my database. So normally, a web page will use in HTTP protocol. And this normally has to talk to your access engine. This is a portal. Now the same select statement, I'll just write within my code, within JavaScript or somewhere. Then what happens is it goes to this access engine. It'll try to compile the data for this. And from here, it goes to the index server from there. So directly from the applications, when you're trying to use this, then we can go for directly to your HANA server. But if it is an web access, then it has to be directed through access engine. Then from access engine, again, it goes to your index server. For statistical purpose, say for example, how much time the data has been loaded, what types of tables are there within the system, all then after that report how much time it has taken. All the statistical data will be available within your statistical server. This maintains of this. How much was your CPU speed? What was the memory consumption? At what time the memory consumption was there? So all these details you can get within your statistics server. So when you go for your pre-processing server, so pre-processing server mainly is used for text processing. So mainly when you try to see the data, right, which we try to store or which you're trying to use in the daily life, so we'll be having two types of data. One is your structured data, and another is unstructured data. So we'll be having two types of data. One is structured data, another is your unstructured data. So structured data, always your organizations, when you try to create a sales order, purchase order, right? Then after that for salaries, accounts, employee tables, master tables and all. So always we try to use your structured data, and structured data will be stored in a table. Got it? And in order to get the data from this particular structured data, so we'll use SQL language. Got it? So in structured data, we'll be having a table, and a table has rows. Every order will have rows, and we have columns. So this type of data is a two-dimensional data. That is, we try to store the data in rows and columns. These rows and columns, we try to store the data. So for this type of data, we'll try to use this SQL language, SQL language, in order to fetch the data and display the results. And we have another type of data, what we call it as in structured data. We try to store this data within your info cubes, or we can call it as a cube. So these cubes, what happens is, it is not row and column, but we call this as multi-dimensional model. So we call this an MDM model. So where it does not have a single table, but it has got the structure of a star join. It uses a star schema, star join, or we can call it as a star schema. The model what we use is a star schema. So star schema mean to say you will have one fact table. This we call it as a fact table. So fact table will store your transaction data. And star schema has dimension tables also, and these dimension tables will be linked to your fact table like this, multiple dimensions. So a group of dimension tables linked to your fact table, we call this as a star schema, or a single fact table surrounded by multiple dimension tables, we can call it as star schema. But you can have only one fact table, you cannot have two fact tables. So here I'll try to show here. So this is your fact table surrounded by multiple dimension tables, or dimension table linked to fact table. And these dimension tables consist of master data. And this consists of transaction data. So master data like material master, and I can have customer master here, customer data, and vendor data, and time data. So like this I can have multiple master datas, and after this, in this, linked all this material, then customer, vendor, I'll have these columns, and time, what date it was been done. After that you'll have quantity, what was the price, what is the amount. So all these key figures, right, or measures will be there within the fact table. So fact table is nothing but a combination of master data as well as your measures. The group of dimensions and fact tables, collectively we call this as an info cube. And this dimension, this diagram looks like what? This is looking like a star. So people call this as, the architects call it as, the design we call it as star model or star schema. So now here when I go for the table, we'll use SQL, but this is a multi-dimensional structure, and star schema is a multi-dimensional one. So we will not use SQL, but we have to use one more language called MDX. Normally, let it be BW or Oracle or SIS, then Microsoft, let it anything, like, right? So they also use in the data warehouses the cubes for data warehousing. Then for that we have to use the reporting tools, will use your MDX. So in BW we'll be having Bex analyzer, and Bex analyzer always it generates MDX, go to your BW server, then fetches the data from here, right? So the funda is, whenever you have your two-dimensional structure, we will be using SQL language, and whenever you have your the data is in your cube structure, then we have to use this as an MDX language. So MDX stands for multi-dimensional expressions. Okay, so MDX stands for multi-dimensional expressions. Cool. Okay, I'll try to erase some part of it. Cool. Anyone has some doubts? Fine. So now unstructured data, like we can see that nowadays, like we can have Facebook, Twitter, emails, PDF files, right? The data is not structured. The data will be there in your emails, then Twitter data, Facebook data, so right, social media data, then PDF files, then Excel files. So all this data is available with us in an unstructured format. And from here, we need to read the data, then find out the analysis. We need to analyze the data from this. Okay, so whenever unstructured data is there, then we can go for your text processing. Your structured data will be there within your index server, stored in your tables here. Got it? Fine. So coming to this, name server will give you the whole topology of the whole landscape information will be there within the name server. Second, index server is the main core for us. For text processing, we have your text processing server, pre-processing server. Then as a all the web development for your Java applications or HTTP applications, all has to interact with your Access engine. Then after that, we have your statistics server, which will be giving me the statistical information. Okay. Fine. So this is what we have, and I'll try to show you the practicals, because so my mode of thing is I'll try to demonstrate you the theory. Then after that, I'll try to show you the practical, like how it is there in the server. Okay. So let me delete this and go back to my HANA Studio. Can you see here, like this is my HDB. HDB always stands for your HANA database. And the user here is system. So when I double click on the server, the connection, then here you will be seeing the statistical information here.
We're not able to see
the screen. Can you see now?
Yeah, now we can see.
Okay. So now when I double click on this connection, what I've been created, then you can see here that this is a general information about the server when it is being started. Now here, whether it is a distributed system or not, whether you have multi-nodes or it's a single node, that you will be, because here it is a single node, so it is showing this as it's not a distributed system. And from here itself, you can find out what is a version of the server which we are using it. So this is my BW on HANA. So here this stands for 1.x, and this shows the version of the service pack of your HANA. So this is 1.x SP12. Okay, this will be your revision of your database. So main thing will be this. So what is the main version of your HANA database, whether it is 1.x or 2.x, and this shows your service pack which you're using, whether it is service pack 10, 11, 12. So after 12, you have to migrate, we have to move it to, upgrade it to 2.0. And what is the platform you're using it, whether using Red Hat or using SUSE Linux, and what is the version of this particular operating system. So this is the OS on which your HANA database is running. So to be clear, HANA database cannot run on Windows Server. We have to run on Linux server only. And this is the kernel. And what are the installed plugins, right? Okay. Now coming to this, we'll be having your SAP HANA memory. So you can see here, the total RAM which is available here is 26.37 GB, right, which is used for SAP only. And resident RAM is the total RAM which is available in the system. So this server is 32 GB server. So within 32 GB, now current consumption of your database will be 13.38, and the peak it has gone to 13.40. Okay. So this is the total RAM which is available in the system. So this shows the RAM of your HANA database used. This will be reserved for your HANA database plus your operating system. Altogether, it will be consuming up to your 13.38. Okay. Fine. So again here, what is the percentage of your CPU usage? Out of 100%, currently it has gone to your 4% use. Max it has gone to 6%. So the more the usage consumption of your HANA database, then automatically there is a lot of processing happening, then CPU may go up to 80%, 90% also. Cool. Second, this is a disk storage, right? The drive where your data will be stored. So we have your data volume and we have the log volume. Now, I'll give some more theory about this. Okay. So data volume and log volume. And this is for trace volumes, and all the database traces will be stored under this particular path. Now when I go for more information, it will take me to the place where this particular data is being stored. For example, the path is /HANA/data/HDB, and within this the try MNT0001, right? So for us the main is the data log and log volume. So data volume and log volume. So these are the two volumes normally we try to store the data. So you can see here the data volume, how much it has been used. It is 31 GB is being used up here. And the log volume is approximately 5 GB of the data. Cool? Now, coming to the theory here. Let's say, for example, you have your server here. This is your HANA server. And within the HANA server, so let me take here. So the whole HANA server will be installed where? Within your RAM itself. I think this is going out. Okay. I'll take like this. This is my HANA database. So within the HANA database, this whole data, whatever we have it, so this we think, say for example, this is my RAM. And the total RAM, what we have is, say for example, I have 32 GB. So out of this, I'm trying to use, say for example, 21 GB for my HANA database itself. Okay, this is 21 or 25 somewhere. So I'm trying to reserve this for HANA itself. Whether you want to increase it or decrease it, that can be done within your HANA database itself. Out of 32, I want to use this as 25, right? Another 7 will be used for your operating system and other purposes. Cool. So now within the RAM, when my server starts, then the main server which will be installed is, we have the name server is fine. I'll take it a smaller one. Then after that we have statistics server, yes. Then we have pre-processing server. So they're all the servers. And the main server which you'll be having is your index server. I'll take a little bigger for explanation. Now, index server is the main server in which your database will be stored. Okay, so we'll have two types of databases which will be stored, or the two types of tables which will be stored. So that is your, one is your row store table, and the second type of table will be your column store. But basically they are all tables only. Collectively I call this as these are all tables. Now as a user, now what you want to do is, you want to create one table, right? You tell, for example, create a table called EMP table. You want to create an employee table. Now whenever you tell that, create one employee table within your HANA Studio, within the HANA Studio, when you create statement for creating an employee table, then what happens is, whether it is row store or columns table, we have to decide it. So then it try to create this within your RAM itself. So first the database creation will be done within the RAM. And if you want to insert some data, I'll try to create some insert statement here. Then I'll try to insert some data here. So this data, whatever inserted, will be filled within this particular data. So everything is happening within the RAM itself directly. Now say for example, when I stored the data inside this, and by chance the power supply goes off, okay, there is no power, there is big failure of the power happening up, then the whole servers, whatever is there, everything is getting washed away. So total RAM now, whatever you have it, there is a blank data, means you're going to lose this data here. So in order to have this backup of the data of your database, then what happens is within the server, within the HANA server, normally we'll have your hard disk, HDD, or it can be solid state disk also, fine. So I'll take it as hard disk, we understand better. So within the hard disk, some space will be used for your operating system, that is your Linux. This is your Linux. And whenever in the hard disk itself, you'll be storing some space for your HANA folders also, HANA database. Got it? So whenever you start your operating system and when your HANA database has to be started, so then OS will give some commands so that your HANA database is started in the RAM. And we have another block of data, so I can have another space here for the backup of this particular tables, right? Row table or column table. We'll try to store this data within the database also, right? This all the data will be stored within your database also. And there will be two types of storages within the data in the database table hard disk. That is your data volume, and another is your log volume. Got it? So this particular data will be first stored. For example, here I'm inserting, very simple. I'll take, for example, in the employee table, here inserted 100 employees. Is it fine? Now you've done a commit for 100 employees. So we'll think that this data has gone and inserted this. It has created one database. First is your EMP table is created, step 1 with the create statement. Step 2 is I'm trying to insert some data inside this. Okay, this data also is inserted here. Now how many records are there in this table? 100 records are there. The moment I commit here within the database, at the same time this 100 records will be first stored within your log volume. Now how many records here are there here? 100 records. Immediately the data will not be stored in your data volume. It is first stored in your log volume only. Every commit, for every second, fraction of second, whatever you commit and you want that it has to be stored permanently in your database, that copy will be again immediately been put up into your log volume every second. Now after, say for example 5 minutes, whatever the data is collected within the log volume, for example it has gone to some 50,000 records, right, over a period of time, for example 5 minutes. So this whole data will be again pushed into your data volume. So after copying into this, I'll be losing this data and this copy will be written to your data volume permanently stored here. So within this 5 minutes, basically we can divide here, for every 5 minutes as a batch job, this data will be copied from your log volume to your data volume. So because every second I don't want to store the data within my data volume, so let it happen within the log volume only. After a stipulated time, say for example the default is 5 minutes. So within this 5 minutes, after this 5 minutes, the data whatever is collected in the log volume will be put into your data volume. Right? Fine. So now after some time we think that the power supply has gone off and everything is being washed away. There is no database at all. Then what you have to do is when power supply comes up, again we'll start your OS first. After that we have to start your database. Once you start your database, there is no database here, right? Now for the backup, it will try to take the whole data from your data volume and put this data within your database, and the whole database will be up. all your tables, everything will be again uploaded from your data volume only. For example, the total data within the data volume, for example, it is 2 GB data. This whole 2 GB data will be loaded into your RAM again. Is it fine? So this is how your data storage will be done. One will be done normally whenever you do your analysis, right? You do your reporting analysis is done from the front end tools like BO or business objects. So they will be consuming the data directly from your HANA database, from your RAM itself. And this data, 2 GB data, will be available 24/7. Now, the reports cannot consume this data directly from here. No, there is no possibility at all. This will be in a file format. You cannot read it. This can be understood only by your system. Whenever the power goes off, then we try to upload the data from your disk back to your database only. So reportings or creations, anything can be done from the RAM database only, but not from your hard disk database. This is just a backup for your main database itself. Cool? Yep. Any doubts, any points? Please come up. I'll just give some 1 minute time. If anyone has any doubt regarding this.
Sir, I have a question.
Yep.
So since we have data volume and log volume, so does that mean that how much ever space we have for HANA database, we will have the equivalent amount of space for hard disk as well?
Yeah. So how much space you have for the hard disk, but our RAM should be still more than that. Actually, again, there is some calculation I'll try to show you.
Okay.
At least we need to keep at least 50%, 50%, 60% more or double also. If you have 2 GB RAM, at least you should keep something like 4 TB RAM there. If you have 4 TB here, then there should be at least some 8 TB there. Right?
Yeah, that's the whole purpose of in memory. Yeah.
Yeah. Because there is other architectural differences also. I'll try to still little more explain in that. Because when it comes to column store data, then there it will be more consumption processing will be done, and we require a little more RAM for that, right? So then your hard disk, we should have more RAM within the system. For example, you have 2 TB, then at least I'll try to keep 4 TB within my RAM size, so that the data, normally when I'm trying to have my column data plus there are other technical things also will come later. So for that it requires more space for that. Yep. Okay, so anything more? Fine. So coming to the point here, because this is the main point for understanding for us, so I'm trying to put this like this. I'm taking this index server, and within the index server, what you'll have, this is your database. This is a whole database. Within this, I'll have some table. And this table data is only this directly within the RAM, and if you want any tool wants to create any tables in the database or read any data from this database, will be done directly from your RAM itself. This is the RAM, and backup will be within your disk, and this will be having two volumes. One is your data volume and another is your log volume. Okay, So first data will be loaded within your log volume. From log volume, every 5 minutes, it will try to load the data into your data volume here. Because the whole enterprise data will be there within your, for example, this may be, for example, 2 TB data. And here also it is 2 TB data. Yeah, both are same here. If I get some new records of 100 records here, then this 100 records will be loaded into your first log volume. After this, get updated every 5 minutes into this as a batch job. But sometimes what happens is within this 5 minutes also, sometimes if I lose this data, right? If the power goes off within the 5 minutes, then the data, whatever is available within the log volume, will be updated within the system, and the old data of your 2 TB will be updated into this. So both as a combined will be having this. Okay. Say for example, if I take like this. Now say for example, now the time is say for example 10 o'clock, 10 p.m. Now I have done some commit here. For the end user has inserted some records into this. Say for example 1000 records are updated. And we know that from here to here, it is say for example 10:05 p.m. and it is 10:10 p.m. So every 5 minutes we have this chart here. So you committed some data of 1000 records here. Yes. So that will be written into your log volume only. So like this, the log volume data will be, what are the commits you're doing it, it's all happening here. The moment it reaches 10:05, the data what is collected in a log data will be updated as batch job into your data volume. Now again, say for example, 1 minute, 2 minute, 3 minute, 4 minute, 5 minutes. Now say for example, again you are trying to do some updations here. So this is my 10:03. So up to 10:03, every single commit will be updated in your log volume. Yes. Now the power has gone off here. Now once power has gone off, now this data is not available in your data volume. But from last 5 years data, I have in my data volume only. This 5 years of data is there. So because for every second you keep committing it, then the database performance, the storage performance, the system performance will go down. So we don't want to do direct commits over this particular data volume. So this will be having empty. So commit will be done very faster. And after some 5 minutes, as a collectively, I'll try to store the data into this. One job, that done. But here, this 3 minutes data is there within the log volume. So it is not updated to this. So whenever you restart your server, then this gets merged with this data. So 3 minutes data also is put into this. As a whole, it will update the data again into this one. It gets emptied off. Okay, so this is the funda of your database backup. What will have anytime, whenever your system, because what are the chances for restarting your server? One is your power outages. Suddenly power has gone off, then this is going to become blank. Sometimes your database, you update some patches from 1.x SP12, you move to 2.x, and you made some lot of updates in the database. Then you have to restart it so that only then the system will be effective. So you have to restart after your patches updations or any parameter changes, right? So in order to do this, then you have to restart compulsorily. So these are most two scenarios what we use for restarting the server. Okay, fine, cool. So coming to your practicality now. Let me show this. Index server mainly for storing the data. The name server will store the information of your whole SAP HANA system, and in a distributed system, the server knows where the components are running and which data is located on which server. Right? And statistic server will collect the information about your status, performance, and resource consumption from other servers in the system. Okay. So what I have shown here is within the server, So you can see here, for example, this is all your resource consumption, what you have in this. Okay. Now I go for your diagnostic files and trace. I'll just backdate this. Okay, so normally you will get this information here, but this mine is a little bit backdated here, so that it shows me this. And so for example, I'll show my date. And I'll try to show directly the physical storage of the data also. So second point is when I go from a landscape, right? So within the landscape, you'll be able to see all your servers which will be started here. So as I told, this is your name server and this is a port it is using, and my host name in which it has been installed is your big data. So my FQSD number will be bigdata.sap.com. Okay, and this is a name server, and we have a pre-processing server that is for text processing, and this is the core server. If this is down, then the whole database is down. You will not be able to fetch any data. If preprocessor is down, there is no problem. The database will be fetched, but you will not be able to do the text processing. Right? Then we have your script server. Then SAP start server. For this is for, because whenever your database starts, right, the start server will be there. And we have a daemon server. So always daemon will be monitoring all your services, and it will start one after the other. So because it will take those, it will intimate to the start server, and SAP start server will start each process. So this daemon will intimate which server has to be started when. And we have a compiling server, all right, for your procedures and other things and all. Okay, so for us main, if you see that the consumption of your memory is mainly done for your index server itself, because the database storage will be done mainly in your index server. Okay, and now so you got all this information about how much is your use space for this, then what is the peak space that has gone off, an allocation limit, right? Physical memory, 32 GB, and what is the skill port it is being using here. Fine. Now this index server will store your data within the RAM. Fine. And when I go to your volumes here, so this is your log volume, this is your data volume. Okay, that is 30 GB of data is being used up, and this is your log volume data. And if I show this more information, it tells us the data is stored in HANA folder, then data, then HDB, then MNT001. So if you want to see this physically within the server, so you can go for the folder, then you can go for SAP HANA, then you can go for data, HDB, MNT001. All right. So within this HDB001, so normally SAP also tells do not touch these files in this directory. Once you lose this information, so when you reload the data, then you will not find the data within the database. The whole thing will be lost. So this should not be deleted at all. Okay, these are the core files of the whole database here. So this will be there in the file format. Cool. So never delete this. Normally you will not have the chance of touching this also, but normally we try to see the data from here. But only thing is when your disk is being filled up, right? It is coming to near your 90% or something. Then at least we can tell to the HANA people or the people who are trying to do it, so they can again expand your disk, the hard disk, so that the storage can be increased. So within the HANA, I can go for data HDB. I'm going to use this, and one more we have. This is your data volume, and this is your log volume. And within the log, MNT00, and you have this data which will be stored in segments. So whenever you're trying to commit the data into your database, first it will be stored in your log folder. Okay, it will be stored in the log. After some particular time, then it goes into your data volume here. Okay, fine. So this is the physical database, what you try to see, the folders where your HANA database within the OS is being created. So normally it will be your exe files, will be your USR, then SAP, then HDB, and HDB00. So this is a path where you find your database. Actually, starting a database and stopping of the database has to be done from this particular path. So for example, I go to my user terminal. So I'm a little going more technical, sorry for that, but at least during my theory, then I'll try to give the in and outs of the whole thing, like how the database started, then how it is being created, where this particular storage is being done, and which format will be there. So you'll get a clear-cut idea, so that anytime you go for interviews, it'll be better for you. Okay, so normally I should be logging to my database. I'll be using as SU HDB ADM administrator. I'll give it as */HDB in capital. Then if you want to see what is the servers which you're running at, I can give it as info. I just enter. And you can see here that name server is running and it is using this much of CPU consumption. Okay, what is the process ID within your OS of your Linux? Okay, this all things will be there. And this is your compile server, then pre-processing server, then data provisioning server. This will come later. And this is the main thing for us, index server and script server. Okay, so out of all these things, you can see that 3.8 is your CPU consumption here. Good. Now if you want to stop the server here, I can directly go to this and give it as stop. When I do this, the whole database will be stopped up. All right. So today I'll not show you, but next time I'll try to show how to stop this and start it. So after stopping it, you want to start it, I can go for start the server. Okay, just click it and automatically start the server there. Fine, then this is the process how we try to start your HANA database and stop your HANA database. And whenever you want to do directly from here, I'll go for your configuration monitor. So from here itself, you can go for start and stop your server. But normally don't do this because you will be having some administrator rights also. So when you stop this, even for your user also, if you're trying to stop it, then it will be stopping the whole database. Okay, fine. So this is where you are in the architecture you might have seen here. SAP Host Agent, right, will be there within your studio. And normally when you want to remotely stop, because you're not directly going to OS and stop the server. So directly from the remote server itself, from the HANA Studio itself, you're trying to stop this with the help of your host agent, right? Okay, this is what we have. So main thing concern for us is whenever you're trying to just go through, because for example, in your projects or your client may be having the server. So he may be asking that what is my database, what I'm trying to use it. The first thing what you have to do is just double click on this, then go to the overview, and finally from here itself, you'll know what is the server version is using it, and what is the server operating system, what is using it, and what are the plugins which is being used in this, right? Then after that, what is your total HANA space, resident memory? You can see this. This is the total memory which is being used up by your HANA, which is there physically within your HANA database. And there is another RAM which is there, 26.337 is being utilized by yours, is being reserved for your SAP HANA. Okay. Now, what is the CPU's consumption? Normally, when you're trying to troubleshoot, sometimes what happens is when you're trying to load the data from multiple source systems, at that time the CPU usage may go up to 90%. After that, again, after 5 minutes, it may come down. So, but you want to find out like what is the main problem, what is the bottleneck, at what time this particular CPU is going more, whether due to the problem with the looping of my programs, or whether it is due to the high loading consumption, or sometimes there is some garbage memory being piled up so that the data is not getting cleared up and it's the CPU consumption or the disk space which is going more, right? So we need to find out with the alerts and other things that will be coming with the basis part, but I'll not try to go a little more on this. Okay, fine, cool. The second part of my architecture we'll try to go for. So normally what we try to do is, now what I'll do is I'll try to create an user for each one next class, right? So that you'll be having your own logins for this. And so because how to create users, how to create roles, how to get the data from different systems, how to report over the data, everything we'll try to cover in detail within the course. And so let me start now. Say for example, okay. So giving this again overview of this HANA architecture. This is your index server. I'm not taking other servers, name servers and all. So mainly we'll concentrate on this particular index server. So in the index server, you will have a session manager. This is the first part. Whenever you log in it, then automatically the session manager will be interacting. Then it will be validating with your authorization manager. If you're authorized, then you'll be able to, the session will be created and you can access your databases. So then after this, we'll be having the transaction manager. So after making the session, then after that, according to your authorizations, then it'll try to, because when you give an SQL statement, then transaction manager will take the request and pass it to the current component, whichever the component it is related to. So once it is committed, then it will inform other components also that there is a commit, and when it's committed from the memory, then it goes to the transaction manager, takes the data and puts it into your data volume. So all this control of your transactions is done with your transaction manager. Authorization manager is for authorizations. Then metadata is data about data, right? Then here we have some engines. Okay, this I will take like this. In SAP, what we have is we have different engines within this. Okay, so I can take like this. This is my HANA database, that is my index server. So within the index server, then I say, for example, this is my database table. Say, for example, EMP table. And this is my salary table. Right? This is also a salary table. Now I'll join this EMP table to salary table. So connectivity also I want to do it. But this all connectivities, everything has to be done in the model. Right? So, or I'll take it out like this. So this is your basically tables. Now, over the tables, now in HANA, what we do is not only it is used for storing the data directly within your database tables. The second is like a data warehouse. We have the second part of this is we have to create a model for reporting. That means I create one calculation view. Right? So this views will be, this is a physical storage of the data, employee data and salary data. The user will try to fill in the data, insert the data. Now, but I want to combine this data of employee master as well as salary in my particular modeling tool. So for this, what you do is I'll utilize this EMP table as well as salary. In this, I'll try to join this table and take one concrete view from both the tables. I want some five fields from here and 10 fields from here. Total, this view will have say 15 fields. And say the tools like business objects, like WebI, will consume this data directly from this particular model. BO cannot consume this data directly from this particular tables. No, this is not allowed. You have to do the reporting only from your models only. Got it? But if you want to directly do the reporting from your tables, then what you have to do is within the BO server, we will be having a separate BO server. Then I need to create a universe here. Then read these tables here. The metadata will be read from here to this. Join these tables in the universe. Now BO can read from the particular tables directly here. So here also we have to do the modeling. This is a BO modeling. So that is one type of modeling we can do it, or we can do this modeling directly within your HANA database itself. That is your index server. Cool. But when you're using BO, we will not be directly reading from your particular tables. We will have to model this calculation views, and these calculation views will be exposed to your reporting tools. These are all your reporting tools. Now, but who is going to compile this? The storage and viewing the data is fine, but who is going to compile this? So for this compiling of this, on top of this, we have one more layer here called your engines. Now, coming to the engines, as I told you that HANA is going to store the data as column store. Another is your row store. For row store processing, we have a row store engine. Just a minute. Okay, sorry. So we have for row store data, we have a row store engine for processing the data. Then for column store, we have join engine. Then we have OLAP engine, and we have your calculation engine. All right. So in the previous versions on SAP HANA, so we had three types of models. One is your attribute view. Second is analytical view. And third is your calculation view. So attribute view is for joining this, because I told that I want to create some model on based of this. So these models again, so the models what we have is three types of models what we have here. So one is your attribute views. So attribute views are mainly for joining master data tables only. Say for example, I have material master and material text. Both are master data of material only. This is also material master data, and this is material text. But from these two tables, I want to concretely give one material data, that is your material master. So I want to join these two with your material ID and material ID only. Here material type description, sorry, material type, material group will be there. Here only text will be there. But I want to join this master data and have one concrete master data. So this joining of this particular master data is done with the help of your attribute views. Now for joining this attribute views, we have this join engine. Got it? And this particular attribute view will act as a dimension also. In star schema, this will be utilized as a dimension. As I told you, like in a star schema, dimensions are nothing but master data table storage. The second type of view, what we have is analytical view. So analytical views will have your cube structure. That is multi-dimensional structure, which will be having a fact table as well as multiple dimension tables. And in order to read the data from this view, you should use your OLAP engine for this directly. It's not the tables. It's not the tables. We have to use it as an OLAP engine. So in BW, this is equal to your info object, characteristic info object, char info object, because characteristic info object is going to store master data. And this analytical view will be equal to your info cube. Right? Now, in BW, what here happens is, this is, for example, my sales data, and I have another cube. This is my delivery data, delivery cube. So some management people want to use only sales data to be reported from here. It is easy for me. There is only one data mart, subject-oriented data. And another division of people who are there from delivery people will try to read the data from here. But the top management out of all these people, this guy belongs to both the departments, and he wants to create a report and extract the data, report the data from both these particular tables. Then what I have to do is, I can create one more view, which we call it as a calculation view. Got it? So this is one cube, this is one cube. So joining of these two cubes will be done within the component called calculation view. And this calculation view in BW, we call this as a multi-provider. And in order to compile this, execute this particular model, we have your calculation engine. It is not only two things, right? I can take another one as my billing. Okay, so sales, delivery, billing, all three I want to use it, or another table I want to use it. So multiple objects or multiple views can be joined and make one concrete calculation view. Now this calculation view and another cube, I can do it again another calculation view. So like this, we can combine multiple targets within one view. That is what your calculation view does. So we have two things. One is your attribute views, join engine, then analytical view, OLAP engine. This will be using your MDX. Okay, OLAP is your MDX. Then after that, we will use your calculation engine, which will be used up, which will be equivalent to your multi-provider execution compiling. On top of this, we will have your SQL optimizations. Normally, SQL optimizer will see, for example, you have different destinations, right? Now, I want to reach this destination, either I want to go like this and get this. There is also possibility of SQL, and there is another possibility, and it will take the best possible way of executing what SQL statement, what combination has to be done. It can optimize and get you the best results of this. Okay. So in SAP HANA, I'll tell first layer will be your database tables, physical storage of the data. Second layer will be your models, whether attribute view or analytical view or calculation views, we have to model it. So this is a job of the modeler, what we will be doing it, right? First we'll create tables, then on top of this we have to do the models. So third layer is what? We have your engines. Now what are the engines? Calculation engine, analytical engine, join engine, and row engine. So these are the engines which will be there on top of this. Any query comes from this particular BO, business objects. Then transaction manager will take the request. If it is an SQL, it will go to this particular master data. If it is an MDX cube, then transaction manager will give it to your VOLAP engine. And VOLAP engine will take to this particular cube data and dimensions and fact table, then it will retrieve the data from that. Okay, fine. So my scribbling, normally while teaching, I'll do a lot of scribbling and all. So by chance, if you're not understanding or something you're confused, you can tell me so that I'll try to go in a different way. Got it? But the main point is when trying to explain it, I want that you need to understand the basics, basically, from this, what is what and how it is being done there. Cool. So let's see what's the time. So 10:34. So then, shall we leave for the day? So in the next class, tomorrow, then what we'll do is we'll try to log in into your HANA Studio. Let me delete this. And I'll try to create multiple users for each and every one, so that we'll start creating some tables inside this. So for example, I'll just show you here. All right, I'll go to user 1. Say I have some EMP table, say for example I have orders table, right? Then I can close this. Now this is my orders table and I have an SQL console here, right? If I want to fetch the data from here, I can just write it as select star from orders. Okay, after that you can just execute this. You'll see the data which is going to come up from this, just like a normal database. So in the next class, what you do is I'll try to show you how to just install, how to connect to your database. Okay, then after that we'll be starting the discussion about your catalogs and content. So first we have to create your tables and views and other things and all. We'll start with the schema. So this is the main core. So tomorrow class will be a little more useful, very fundamental. You need to understand it. So because the catalogs and contents funda theory and all is very important, so we try to start with this. Okay, fine then. Good night for today, and we'll try to meet tomorrow also at the same time, 9 o'clock to 10:30. So we'll try to have as daily as much as possible, because I don't want to just stretch for 1 month, 2 months, 2 months and all. So as much class we can take it. Say for example, if you're going a little later, then at least we'll have from 9 to 11 o'clock. So that, because I have other commitment for the batch, if that is finished, then I'll try to start the batch from 8 o'clock itself. So we can have 8 to 10 o'clock. So at least 2 hours we try to take up. Then at least we can understand some concepts, as well as from the next class, I'll try to give you some practice for doing some creation of your tables and all, right? And still, we need to discuss tomorrow. There is a lot of things to be discussed regarding your row table and column table, right? So there is another important topic, what we try to do it. So this is what we explained today. Like in memory, we have the data here in a table, and any commit which is being done. So first it will be saved in your log volume. This is a persistent storage. Persistence is a permanent storage, that is your hard disk or solid state disk. And at regular save point, regular intervals, that is the default is your 5 minutes. Okay, so for every 5 minutes, the data will be put into your system there. So tomorrow I'll try to discuss more on your column tables. Then after that, we'll see how the storage is and other things and all. I'll try to discuss more on it. Okay. So when you go to your system, HANA system, so you can go to your configuration. Within the configuration, you'll have one global.ini file. Within the global.ini file, you go to the parameter called persistence. Within this, the parameter is save point underscore interval underscore s is 300 seconds, which comes to your 5 minutes. If you want to make this data, right, whatever you're committing it after an interval of 10 minutes, if it is saved, then you can change this interval to 600 seconds. Okay, or if you want to reduce it because you think that the power outages may go more and you don't want to take risk, then what you can do is you can make it as, say, for example, 150 or 100 seconds, whatever it is like. Okay, so this comes here. Say, for example, when you go to this, just double click on the system, go to your configuration. So within the configuration, that is within your global.ini file, actually it will be there here, or just filter from here. So within your global.ini file, within the persistence, you'll have your save point underscore interval underscore s. This is the default one. If you want to change this, just double click on this. The default value is 300 and you need to make this, say for example, 600. Now click on save. No need to restart the server. The system will automatically apply the values immediately after clicking on the save button here. And if there are multiple hosts in a distributed one, then what you can give is you can give this for each host what time this particular value has to apply. Whether it's applied to all the hosts or a particular host, what you can select from the list and click on, give the new value to this and try to save it up. Okay. Say for example, I try to change this, for example, 600 and make this as, say for example, 600 for all the servers. Click on save here. Now it says that default value is 300, what is given by SAP, but now you change this to 600 seconds, right? So after every 10 minutes, the system will try to commit the changes. Even power goes off, then you'll be having the whole data available there, all right? This is for log volume and data volume storage configuration. There's a save point interval. Cool. Fine then. So let's pack for today and tomorrow morning. So just go through, because now internet is available. Go through the Google, then whatever the topic what you just discussed it, so you can find out more of it. And if you have any more doubts, then tomorrow before starting the class, say 5-10 minutes, we'll discuss about any doubt clarifications you have it. I'll try to resolve it. Not a problem, right? Okay, thank you. Bye bye. See you for the day.